Hey everyone, this talk we will discuss how to write a custom Spark data source. We can distribute the work of extracting data from database tables and from APIs by extending Spark's data source API. Spark distributes the work by having a driver process and executor processes. The driver is responsible for assigning tasks to the executors, and the executors are responsible for the heavy lifting of completing these tasks. These processes don't all run on one machine, and often if you're running in a cluster infrastructure, you'll see something like this. If you're running in client mode, the driver will be running on the master node, and the executors will be running on the worker nodes. Spark can distribute our work like this if we can break it into parallelizable tasks. Here's an example of using a Spark data source. You may have used it yourself if you ever had to read in a dataset that was written in Parquet format. So how do we create something like this for reading data from a specific API? Take this temperature API. It outputs temperature readings that took place within a given time frame. It takes in two parameters, a start and end time, which represents the time frame. Let's try and create a Spark data source for this API. First, we just want to create a simple class that can make a request to the API. It takes in a base URL and the parameter names and values we want to pass to the endpoint. Then we want to create a DefaultSource class that extends the Spark's relation provider. The createRelation method needs to be implemented to return a relation, a class we will implement later on. In the createRelation method, we also take the time to transform the parameters variable into an options class that is more specific to this data source. The MyApiOptions class contains all the options we need to take in from the user. The base URL from the API, the schema of the data we will receive from the API, and the start and end parameter names and values we want to extract from. And finally, the partitions value, which decides how much we want to parallelize the work of extracting this data. Now to define the relation we want to return in our data source. The relation consists of a schema and a buildScan method, which returns the raw data in the form of an RDD. For this schema, we parse it from the user's input, but for other data sources like database tables, the schema can be constructed from a query from the table. The RDD returned from the buildScan method is where we will put the logic of how to break up the work of extracting the data for a given time frame from this API. An RDD consists of partitions. Partitions are like defined units of work or tasks. They contain the information needed to construct a portion of the RDD. For example, this partition contains a start and end time for which it will extract data from. And this start and end time is just a portion of the total time frame the user passed in. We use the number of partition the user specified in the options to construct each partition. For example, if the user specified a time frame of 10 days and a parallelism of 5, each partition would extract 2 days worth of data. Now we put it all together. Our RDD implements the getPartitions method by calling the partitions method we defined on the previous slide. The compute method is where the actual work is done. In our case, one of the requests is made to the API and the response is parsed and converted into rows. This is the work that will actually take place on the executors. Now that we have all the Spark data source classes defined, we can use our custom Spark data source to extract data from our API. We want to define the URL we want to hit, the start and end parameter names, the start and end values for which we want to extract data for, the schema of the data, as well as the number of partitions or how much we want to break up the work of extracting this data. Then we want to use Spark to read in this data, so we just need to specify the class path to our definitions. And now that we have our data frame, we can perform transformations and actions on the data in order to get things like the average temperature for the last month. And when we run this, we can see that our data source correctly broke up the work into 8 parallelizable tasks. So there's a couple other things you can do with Spark's data source API. For example, you can extend the data source register, so you no longer need to call your data source default source and you can correctly name it. You can also extend schema relation provider, which allows the user to pass in a schema. You can also implement prune scan, which will allow you to work on a subset of the columns. Also, prune filter scan will allow you to push down filters into the data source, and also insertable relations, which adds the ability to insert data into the data source instead of extracting from it. Thanks for listening. If you want to see some more detailed examples of custom Spark data sources, you can find them in the Spark repository.